So now we'll discuss a bit more the difference between radians and degrees. So here I have a point I can move around, right? You see a lot of numbers. One of the numbers is this one. This measures the angle from the x-axis here and up to this line that I can move around, this line, in degrees. So this is 121.96 degrees, right? You can also see some numbers here. So this point here has an angle of, not an angle because you can see it also depends on, but the length of this arc here is 66.71. This is 44.47, right, and so on. So if you put the radius to this, then you get 90 degrees here, 60 degrees here, 45 degrees here, and 30 degrees here, right? That's what you get when you measure these things in degrees. And then I could put the radius to 1. Now you can't read anything, but the point is that we can zoom in, and then you will see what the corresponding numbers are in radians. So this strange number here, 1.57, and then in fact many more digits, you can't write up them all because they're infinitely many. This corresponds to 90 degrees, but if you notice, radius here down here is 1, right? So this you can just write as pi half. 60 degrees corresponds to pi third. This corresponds to pi fourth. And this 30 degrees corresponds to pi sixths. So when you measure things in radians, usually you will do it as a multiple of pi's, right? Because then 180 degrees corresponds to what? Well, we can just move this down here, right? What is it? It's one pi, just pi. So here you can always see what the angle is in radians and what the corresponding angle is if you measure it in degrees. And the way the two concepts relate is just a scaling factor, right? And that scaling factor is given by the fact that you have a huge circle and you have a very, very small circle, right? And as I said, mathematicians prefer to measure angles in radians. We will soon see why, one of the many reasons why. But for now, I hope you now have an idea of how these two concepts relate and how you can get from one to the other by using these relations.